All right, this is chemistry's first quarter test review. This is the third video. We'll be covering chapter 3, 4, and just a little bit of chapter 5. And then you will be ready for the test. So you'll need your notes. We'll be using your calculator just a little bit. Or the review questions, you need that. And before I get started, if this video helps you, please consider buying me a coffee. There will be a link in the description box, or you can scan the QR code. All right, so number 1 of chapter 3. Says a chemist mixes 40 grams of calcium with 40 grams of sulfur. So we have calcium plus sulfur, and that makes 72.1 grams of calcium sulfide plus some leftover sulfur. So we have 40 grams of calcium, 40 grams of sulfur, 72.1 grams of calcium sulfide, and then some leftover sulfur. And we don't really care about how much of the leftover sulfur there is, but it'd be pretty easy to figure out. Now, before we get started on our process, because we're trying to see we call this a recipe problem, right? So what amount of calcium and sulfur would be necessary to make 0.75 kilograms of calcium sulfide with no leftovers? Okay, so we need to figure out how much of this 72.1 grams is calcium and how much is sulfur. Well, you know all of the calcium got used up because there's no leftover calcium. So for calcium, there's 40 grams in that 72.1. So how much sulfur is there? Well, there would be 32.1 grams of sulfur. The way I got that was just take the total, 72.1, and then subtract out the 40 from the calcium, and you're left with 32.1 grams. So we need to know those two numbers. So we had 4 steps with these recipe problems. Step 1 is we just want to write down the total mass in the trial run, excluding leftovers. And then part 2, we want to have a little equation, and that's 72.1 times x, and then that's equal to the total amount you want, which is 750 grams. Now it said 0.75 kilograms. Remember, 0.75 kilograms would be 750 grams. You would multiply that 0.75 by 1,000. There's 1,000 grams in a kilogram. If you need to, go through the process there. And we can get rid of the units here. So we solve for x. X is going to be 750. We'll divide both sides by 72.1. And I want to take this number out a little bit, okay, so we get a better estimate. So 750 divided by 72.1, that is 10.4, and that's probably enough since it's O2. So 10.4 is our multiplier. So our recipe, what you do is you take calcium, and it's 40 grams, all right, the amount right here, 40 and 32.1, 40 grams times our multiplier, 10.4. All right, so 40 times 10.4 is 416 grams. And for sulfur, it's not 40, it's how much is a part of this 72.1, which would be 32.1. And we multiply it by 10.4. And that is 333.84. That'll round up to 334 if you want to put it that way. And then we want to add these two together. So this is our recipe. This is our answer. We want to add those two together and see if they add up to 750, and they do. So if you didn't round up to 334, then it would be slightly less than 750, but no problem. Because we didn't take this out more decimal places, we'll be off just a smidge. All right, so that was step 4. So your answer is right here, 416 grams of calcium, 334 grams of sulfur. Now make sure on the test that you label it properly so that your teacher can grade that and know which mass goes with which element. All right, let's take a look at another recipe problem. Number 2 says 391 grams of potassium is mixed with 500 grams of chlorine to make 746 grams of potassium chloride plus some leftover chlorine. How would you make 150 grams of KCl with no leftovers? All right, well, let's write out an equation. We have potassium plus chlorine, and that makes potassium chloride plus some leftover chlorine. We're starting out with 391 grams, 500 grams of chlorine, makes 746 grams, and then some leftover chlorine. Now, out of that 746, I need to know, since there's less leftover chlorine, that means we used up all the potassium. So of that 746, we have 391 grams of potassium. And the way to get the amount of chlorine would be 746 minus 391. And that's 355 grams. All right, so now we're not doing a balanced chemical equation. For this exercise, it doesn't matter if you have the Cl2 and balance it, okay? So let's start. Number 1 of our process, we have 746 grams of total product, okay, disregarding leftovers. Number 2, we're going to have a little equation, 746 times x. We're going to set that equal to the desired amount, which according to the problem is 150 grams. So x is equal to 150 divided by 746. Okay, so our multiplier is 0.2. I'm going to go ahead and carry that out to 0.201 this time. So now we can figure out our recipe for potassium. It's the total amount used, which is 391, times our multiplier, 0.201. And then for chlorine, it's the amount used, 355. We're disregarding those leftovers, times 0.201. All right, so we have 78, I'm going to go ahead and round that to 0.6 grams of potassium. And 71.36, I'm going to go ahead and round that up to 71.4. That's your answer, that's your recipe. Now that's going to add up to 150 grams. And if you round it a little bit different, it'll be really close to 150 grams. So you'll know it's just a matter of the rounding there. But this is a totally fine answer right here. Remember to label it so you know potassium's the 78.6 and chlorine's the 71.4 there. Okay, there's a couple of recipe problems. That's the only problems where we really need the calculator. So let's take a look at number 3. So it says, which of the following are ionic? Okay, we have Li2O. We have NO3, C3H8, and CaCl2. Well, ionic will have a metal and a nonmetal. So lithium is a metal, oxygen's a nonmetal, so lithium oxide is yes. Nitrogen and oxygen are both nonmetals, so that's no, not ionic. Carbon and hydrogen, nonmetals, so that one's no. And then calcium is a metal, chlorine's not, so that's yes. So we have lithium oxide and calcium chloride for number 3. Number 4, we want to give the chemical formula for diboron hexafluoride. Now you will get your periodic table on the test. Okay, so diboron, di means 2, hexa means 6, boron, so that would be B2F6. And then the next one is carbon tetrahydride. All right, carbon, there's no prefix in front of it, so we know it's 1. Hydride would be hydrogen, and tetra is 4, so CH4. All right, awesome. Now, you definitely don't want to miss any of those naming problems on the test. So we want to spell the name. The first one is Na2S. Okay, that's ionic. We have a metal and a nonmetal, so we don't need those prefixes. This would just be sodium sulfide. All right, we have SO3. So that's covalent, so we have to use the prefixes. Now, you don't have to use mono since it's the first one. So that's going to be sulfur trioxide. And they are, you don't capitalize. Be2O. Okay, that beryllium's a metal, so this is ionic, so we don't need to have any prefix with that too, so that's beryllium oxide. And then the last one is C2H5. That's covalent, 2 nonmetals. And so we would have dicarbon. And then 5 is penta, so pentahydride. And there you go. So hopefully you didn't have, if you learned those in Chapter 3, then you don't really have to study a ton of the naming problems. But if you had trouble with it, go back and memorize those prefixes. Okay, number 5 says to balance, so this would be Chapter 4, and then 5A also. So that's number 1 would be Cu2S plus O2 makes Cu2O plus SO2. So I'm going to take you through my process. So I see I need 2 oxygens. Okay, so I've got 2 here and I've got 1 here. Copper is balanced, all right? So really let's see, copper's balanced, sulfur's balanced. So really it's oxygen that isn't balanced. So probably what I would do, we've got 3 over here on this side, 1, 2, 3. And we have 2 over here. So in order to get 3 over here, we could put a fraction 3 over 2, 3/2 in front, and then multiply everything by 2 to clear that fraction. Let's see if that works. So we'd have 2 Cu2S plus 3O2 makes 2 Cu2O plus 2SO2. So let's count them up. We have 4 coppers on this side, 4 coppers on this side, 2 sulfurs on this side, 2 sulfurs on this side, 6 oxygens on this side, and then 2 plus 4, 6 on this side. So the fractional way really saved us a lot of time, or at least a lot of effort of trying to just make some guesses to get it. So I love using the fractional way, but you could probably also guess your way into the right answer on this one as well. All right, number 2, we want to balance. We have aluminum plus NiSO4. That yields nickel plus Al2SO43. Okay, one thing to remember on this is that SO4 is a polyatomic ion. It's this one in parentheses. We really don't want to mess with that. Okay, we want to leave it as a unit. So we have one of those right here. I know I have 3 SO4s on the right. SO4, all one unit. I have 3 of those. So let's try putting a 3 right here. That gives me 3 nickels and 3 SO4s. So now I have the same amount of SO4. So I need a 2 in front of aluminum because we have 2 aluminums, and a 3 in front of nickel. So it's balanced now, and it's so much easier if you just leave that polyatomic ion. Think of it as a unit and balance it on both sides, right? See, you could even think of that as this. We don't write it that way, but it's SO4 is in parentheses and there's one of them, right? We don't write it that way since there's one. You don't have to write the parenthesis, but that's the way you can think about it. All right, so that's a quick balance on that one. Number 3 says, and so now we're into the chapter 5a part. Write a balanced chemical equation for the combustion of C4H14. So we're assuming complete combustion. All right, so what you do is for a combustion reaction, you add oxygen, O2. Remember, oxygen is a homonuclear diatomic. It is a 7 that starts with 7, right? Oxygen right here, part of that 7. So we have to write it as O2. Now, complete combustion makes 2 products, CO2 plus H2O. You just have to memorize that. Hopefully you did for your most recent test. And now we can balance, and I can see we're probably going to have to use a fraction here. So we have 14 hydrogens. Oh, let's start with carbon. We have 4 carbons, so I'm going to put a 4 right there. We have 14 hydrogens, so I'm going to put a 7 right there. So now hydrogen and carbon are balanced. Oxygen we leave to the last. On this right side, we have 8 oxygens plus 7. That's 15 oxygens on the right. So I need 15 over 2 in front. 15 over 2 times 2 gives me 15. We're balanced, but we can't leave it like that. That defies convention. So if I multiply everything by 2, both sides, we have 2C4H14 plus 15O2 yields 2 times 4 is 8 CO2 plus 2 times 7, 14 H2O. So that is balanced. You can count them up if you don't agree. But we've got 8 carbons over here, 8 over here. 28 hydrogens on the left, 14 times 2, 28 on the right. And then we have 16 plus 14, 30 on the right. And 15 times 2, 30 on the left. Boom. All right, number 4 says give the balanced chemical equation for the formation of zinc nitrate. So that'd be ZnNO3 And if we're forming it, it goes to the right side. So on the left side, we just have the constituent individual elements, zinc. And then we know that nitrogen is a homonuclear diatomic, so we write that as N2. Oxygen also a homonuclear diatomic, so we write that as O2. And now let's see if we can balance. So we have 2 nitrogen on the right. Remember, there's 1 here times 2 on the outside. So 2. Nitrogen is balanced. Zinc is balanced. We have 6, 3 times 2 oxygens on the right. So I just need a 3 right there, and we are balanced. Okay, 6 and 3 times 2 is 6. So not too bad on the balancing there. And finally, we want to give the balanced chemical equation for the decomposition of PbCO3. So lead carbonate, PbCO3. If you're going to decompose that, it's going to decompose into its constituent elements. So lead plus carbon. Carbon's not a homonuclear diatomic. Don't write C2 plus O2. Now remember the trick. You know, we could try a fraction here, but we have 3 oxygens, 2 oxygens. So let's put a 3 out front here, a 2 out front here. We'll do the old switcheroo there, and I have now oxygens balanced. I've got 6 on the left, 3 times 2, 6 on the right. And then lead and carbon are easy to balance. There's 2 leads on the left and 2 carbons. All right, so there you go. That does it for the quarterly test review. Just real quickly, I will give you some suggested problems. Hopefully your teacher has already given you those, but if you wanted to rework some problems from the book, the suggested homework rework. Okay, what problems would be best to rework? So hopefully you've already started on this, but from chapter 1, it would be review question number 7, practice problems 1 through 10, and extra practice problems 2 through 13. For chapter 2, it would be practice problems 1 through 3 and 5 through 10, and then extra practice problems 1 through 10. For chapter 3, it would be practice problem 5 and 8 through 10, and then extra practice problems 3 through 6 and 8 through 10. And then for chapter 4, it would be practice problems 4 through 10 and extra practice problem 4 through 10. And then chapter 5, practice problems 1 through 3 and extra practice problems 1 through 5 and 7. So hopefully you've already started on some of those. But if you work through all these, you should be super prepared for the test. Okay, so there you go. Once again, I'll plug my Buy Me a Coffee site. If this video helped you, please consider buying me a coffee. It's just a $3 donation. They've got a link in the description box. can scan the QR code. The vinyl of the day is, hold on just a second, I'll get it down off the wall. Alright, if you haven't paused this yet, you are quite the trooper. But it is the band Yes, and the album is Fragile. So while you're studying, this is way different than any of the other albums. This is from late 1971, and it's one of the great progressive rock albums of all time. So it has, progressive doesn't mean the same thing as it does in politics with rock music. It means that there's jazz and classical mixed in with the rock music. So hey, give that one a try. I love that album. Just a lot of cool stuff on it. And the opening song, Roundabout, is an absolute classic. So good luck on your first quarter test. Hope you do well, and I will talk to you next video.